A few things I'm going to cover here. Actually, I'll be right back. I have to go grab the book. Sorry about that. Wanted to make sure that I'm covering all the important parts of the chapter. So we're actually going to be talking about securing the CLI and being able to remotely connect different switches. So first thing we're going to look at is something we've done before. So if we go to config or CLI, you can see the first thing we have to do in every switch is type enable. So whenever you have that as your first message, it's getting into the enable, usually you want to secure that. So if we type config T, if you type enable right here and you hit question mark, you can see we can choose password or secret. So if, let's say we type password Cisco, and then we exit all the way out, type enable again, we're going to be asked for a password, and we're going to be asked to type in Cisco. So if we look at our running configuration, you can actually see here that the enable password is set and it's Cisco, but that's stored in plain text, and we don't want people to be able to see that if they're able to access our switch. So something you can do is if you type enable secret instead, what it does is it is not recommended. So if we do a show run, you can see our enable password is Cisco, and then our enable secret is something different. So usually you only want to have one of these configured, because if we exit all the way out and go back in, if I type Cisco, it's both passwords, right? So one's going to work no matter what. But whenever you actually do this, the secret password is the one that's actually used. This password down here, this password Cisco, is not used, but since there's the same value, it's able to be done. So we want to remove that so no one can see it. So it's no enable password Cisco. No enable password, sorry. And if we do a show run now, you can see that the enable password of Cisco has been removed. So secret will always prioritize over the enable password. So even if I was to go in here and type config T enable password Cisco 1 and I exit out, if I type enable, I know you guys can't see this, Cisco 1, it's going to not work and it's going to ask me for the password again. So if I type Cisco 1 again, basically if you type it 3 times wrong, it's going to say no, knock you out, go bad secret password. So if you enable, type in Cisco, it's going to work. So we're just going to go ahead and remove the no enable password. Make sure it's nice and clean, and we can see enable secret. And you guys saw whenever I was configuring things, so whenever I type enable password Cisco 1, and I exit out, it gives me this error message and it kind of gets in the way. My cursor is now down here. You have to hit enter to see it again. To stop that from happening, you type line console 0, and then we want to type logging synchronous. And that whenever you type out, it'll automatically put my cursor down here in a clean switch view. So this error message or syslog message didn't get in the way. But this isn't actually the first, the enable isn't the first layer of security. Let's say we want to, you can see here we are in switch console 0, so we're in the console port. So if we want to secure the console line, we can go to line console, we're going to the console 0 where we plug in, and we type password Cisco. So if you look at our options by hitting question mark, we can put a password. But to actually enable that password checking, we have to type login. So if I type login here, and I exit all the way out and hit enter again, I'm asked a password as soon as I hit enter. So type Cisco, enable, Cisco. So all of our passwords are set for our enable line and our console line. But right now, if we go to show IP interface brief, I've got 2 ports connected on 1 and 2 to these 2 PCs over here. And down here, I've got 1 port connected to this other switch, the gig port, and they're seeing that they're all up right now. But if we do a show VLAN, you see that everything right now is in the default VLAN, VLAN 1. We kind of don't want that because normally you want switches to not use the default VLAN. It's just a security risk. So we're going to take those first two ports out of that VLAN, and we're going to convert that gigabit port down here, gig01, to a trunk port. So we're going to go into config T. We're going to do VLAN 10, and we're going to name it users. And that's our configuration for the VLAN. So that VLAN is now created. So if we do a do show VLAN, so if you run a do command from the config mode, it'll let you run show commands. So I'll do show VLAN, and you can see VLAN 10 is created, but no ports are active in it. So we're going to throw some ports in there. So we're going to go to interface FA01, switch port mode access, turn it on to an access port, and we're going to switch port access VLAN 10. We're going to do the same thing for port 2. Switch port mode access, switch port access VLAN 10. So now if we do a show VLAN, you can look here and both of our ports are in VLAN 10. So we're good to go with our users, but we still haven't configured our trunk port. So if we if we go into interface GI0/1 and we do a switch port mode trunk, you can see the status went from down and then went back to up, and that's because right now it's doing it's switched modes to a trunk port and the other side is not a trunk. You can see that these orange lights are now on. It's running through something called spanning tree, which I believe we cover in chapter 7, so it'll be the next topic we talk about. The spanning tree runs through. It takes about 15 seconds to pop up. I'm not sure though if it's actually going to work because one side is configured as a trunk and the other isn't, so I can't remember off the top of my head if these two will come online. We see one light's up and the other one's still down, so it's still working through that process. So another thing is though, we want to be able to access this switch remotely. We don't want to only be able to console into it. So let's say there's an outage and you're in switch 1 but you're physically not able to get to switch 2. You will have to console into it. So to do that, you need to create an interface VLAN. So what this does, interface VLANs are known as SVI, switch virtual interfaces. So we'll do interface VLAN 10 because that's the VLAN that all of our users are on, is VLAN 10. Then you have to set an IP address. So IP address, and you have to give it a subnet mask. So all of our users are in the 192.168.1 network. So I'm going to make this 1.10. And subnetting still hasn't been covered in the book, so we're not going to talk about the mask just yet. Just know that we're going to be using the mask of 255.255.255.0. So if I come out of here and I do a show IP interface brief, we see all of our interfaces are up. We see that our new SVI, which was virtual, is now up. We've created this virtual interface called VLAN 10. 192.168.1.10 is up. So let's say though I would have created an interface VLAN 20 and I did IP address 192.168.20.10 with 255.255.255.0. If we do a show IP interface brief here, VLAN 20 is down. And that's because for an SVI to be up, there has to be a port that is using that VLAN. So right now we've got these two VLANs, these two ports, FA01 and 02, and if we do a show VLAN, you can see that VLAN 10 has this, but the VLAN 20 hasn't even been created yet. Creating the SVI doesn't create the VLAN, but if we were to create the VLAN 20, and then we did a show IP interface brief, you can see that VLAN 20 is now up. But the only reason it is up is because we have a port that is in trunk mode. So if you look at the show run, you can see that we have a port in trunk mode. So trunks allow all VLANs across them unless otherwise specified. So that means that all VLANs that are created on this switch will be turned on. So I don't know why it's showing the MAC address here. I've actually never seen that on a normal switch. But so this trunk port has created VLAN 10 and VLAN 20 and is activated going across. So you can see down at the bottom here we also have these VTY lines. This is the final thing we need to configure to make sure that we can remotely log into a switch. So VTY lines are basically virtual telecommunication lines, and that's how you log into switches virtually across the internet. So we've got, you see here 0 to 4 and then 5 to 15. So what we're going to do is we're going to go config T, and we're going to do line VTY, unlike line console. And if you hit question mark, it says the first line number. So we're going to do 0, and if you do question mark again, it says the last line number. So I can either edit just the 0 line, or I can edit all 16 lines at once by going 0 to 16, 0 inclusive. So this is where I'm going to edit all of the VTY lines. Now if we hit question mark, we can see we've got a bunch of different stuff we can do. But the first thing we're going to do is we're going to put login. So that means it's going to check for passwords. So login disabled until a password is set. So there has been no password set right here, so we weren't able to use login. So we're going to make a password, and we can either hit 7 and put in a hidden password, so it'll be an encrypted password, or we can just type in what we want and it'll be clear text. So password Cisco. Next we're going to hit question mark again, and here we have transport. So this tells you what protocols can be used to log into this device. So if I type transport and hit question mark, I can do input or output. So we're going to do input because we're coming into this device. And then here you can either use all protocols, no protocols, SSH, or Telnet. So I'm going to talk about the difference in these two right here. Obviously we're not going to use none because we want it to be able to be logged in remotely. So we're either going to use all or one of these two. So if we use Telnet, Telnet is a protocol that is unencrypted. So if you type Telnet into a switch and hit question mark, it'll ask you for the IP address or a host name of a remote system. So we want 192.168.1.10. And it's actually logging us in. We just remoted into our own switch from the console line. So it's asking for a password, so I type Cisco again, and I'm actually in the same switch I was just in, but I'm actually in now the, I think so, sessions. Maybe not. But I'm actually in the switch that we were just in. So if I exit, it'll see right now it says connection to 192.168.1.10 closed by foreign host. So that means I logged out of that switch from the VTY line and I'm back into the console line. But the problem with Telnet is it transmits everything via plain text. So passwords, anything you type is all unencrypted. SSH on the other hand encrypts everything. So if we go to line VTY 0 to 15 again and hit question mark, we can see we've got transport here. So we're going to go transport, input, and we're actually going to type all for here. So we're going to allow SSH and Telnet. So something that SSH needs though is that you need a fully qualified domain name before that will work. So we have to name the switch. So I'm going to name it Denver. So the switch is in Denver. And another thing you need to do is specify an IP domain. So IP domain name, and then we have to give it a domain name. So I'm going to give it mydomain.com. So once you have both your host name and your domain name created, I know none of this stuff has been covered, so these two things might not make it. I mean, the host name has been covered, it's just the name of the switch, but the domain name hasn't. That's not something we're really going to worry about right now. This is just covered. This is just instructions on how to actually implement SSH. So you need host name, you need your domain name, and then you need to type crypto key generate. And if you hit question mark, we see RSA. If you hit question mark again, you can see whenever it says CR, that means you hit enter. So it's going to ask us now, we're generating a key for denver.mydomain.com. So we're making a key for this specific device. So this wants us to choose the size of the key. We're not really worried about changing it. Its default is 512, so we're going to leave it at that. Hit enter. And now this key has been generated and we are able to SSH into this device. But first we have to configure the other switch. So I'm going to have switch 1 configuration over here, switch 0, and then we're going to look at switch 1 as well. We'll move this, yeah, we'll just move it right here for now. So we'll go into the CLI. Same thing, we're going to config T, we're going to change the line console 0, turn on logging synchronous. We're going to turn in password Cisco, and we're going to put login. Then we're going to go to enable secret Cisco. Finally, we're going to turn on the 2 ports into access ports into VLAN 10. So We're going to put interface FA01, switch port mode access, switch port access VLAN 10. So we didn't create VLAN 10 this time, but if you type switch port access VLAN 10, it automatically creates VLAN 10. Then we're going to go to FA02. Same thing here, switch port mode access, switch port access VLAN 10. Now that we have both of these created, we want to jump into the trunk port and make sure that it's turned on to a trunk, so switch port mode trunk. And finally, we're going to name VLAN 10. The name is unnecessary, but it's good practice to have names for your VLANs, that way you know what they're being used for. So we went into VLAN 10, we created a name, and now we want to create that virtual interface like we did before so people can actually log into our switch. So we're going to go interface VLAN 10, IP address 192.168.1.20 with a 255.255.255.0 IP address. So if we ping 192.168.1.20, oops, if you run do, you can still run commands that are not config commands from here. So do ping 192.168.1.20, we are able to ping our device. And let's actually try to ping the other side now, 1.10. And we are able to ping the other side. So the trunks are now up and operating like we need them to, and we are able to ping the other side, and our network is fully set up. So let's try to telnet now. Telnet 192.168.10.1. It's going to try. Connection timed out. Remote host is not responding, and I believe that's because we haven't allowed our device to use VTY lines. So we're going to configure our device. So line VTY 015, password Cisco, login, and we're also going to put transport input all. So let's get back out. I haven't set up Telnet in years, and most of the time when I set up SSH, it's with a server. So this is a little different for me. I haven't done it in a while, so I'm going to actually look at the book and see if I missed anything. Oh, usernames. So whenever you are telnetting into a different device, you're going to need a username to actually access it. I completely skipped usernames. So we're going to go into config mode, type username, and we're going to call my username Zach, and then it's going to ask for a password. I'm going to put Cisco. And we're actually going to give this a host name of Seattle. And we're going to give this a domain, IP domain name of mydomain.com. Oh, this actually doesn't cover logging in through Telnet. It just talks about configuring it for Telnet. So we're going to go back into our config T, and we're going to go back to our line VTY 0 to 15. We're going to type login local. And what this does is that it will ask for a local login, which is our usernames, to actually log into our devices. So if we do telnet 192.168.10.20, Oh, I'm using 10 dot something, not 1. There we go. Alright, so if I type the right IP addresses, this might work. So, since I typed login local and I'm using, what that does is that it will, alright, so we'll go back through this again. So whenever you use the right IP address, not 10, we're using the 1 subnet. Since I logged into my own device, 1.20, whenever I went into, if you go to config T, actually we'll just do a show run. And we'll actually look at the configuration, and we'll compare the configuration between these two devices. So if you look here, on the Denver switch, we have line VTY 0 to 4, we have password Cisco, and we just have login. And same with the other VTY lines. I don't know why it breaks them up into two different ones, because I said 0 to 15, but not important. Here, though, I have login local. So if I was to telnet 192.168.1.20, it's going to ask for my username because it's looking for a local username on this device. So I'm going to put Zach, password Cisco, and I'm actually in my other device of Seattle. So now I can make changes just like I could on the other device, but one thing we're going to do here is we're actually going to turn on crypto key generate RSA. We're going to use the 512 module, and we were able to so it's telling us we need to have at least 768 bits for SSH version 2. We're just going to be using version 1, I guess. And let's try to SSH 192.168.1.10. -L Zach. So with SSH, unlike Telnet, you just don't put Telnet and the IP address. You have to put SSH and then you put -L, and this is saying, okay, we're going to log in using the username of Zach. And if we hit enter, we are now back in Denver. So, alright, I'm going to log all the way back out of these switches. Alright. So the things you need to know with SSH is you have to create the fully qualified domain name, which means you have to create a host name, you have to create an IP domain, and you also have to generate the RSA key, so crypto key generate RSA. And then to SSH, unlike Telnet, so Telnet, you just type the Telnet and then the IP address you want to go to. And that'll get you in there, but for SSH, you need to type SSH-L, the username you're specifying, and then the IP address you want to use, 192.168.1.20. But let's actually try to SSH into Denver, for example. So -L Zach 192.168.1.10. Did I create usernames on here? So although I'm logging in with a username on Denver, I believe this is just something with Cisco Packet Tracer because it shouldn't work, because the username Zach does not exist on Denver. So I believe that's just a bug with Packet Tracer, because the usernames must be defined before you can log in with them, or else it wouldn't really make sense for this login to work because there's no username of Zach on the other side. So that's just something you have to remember, is that whenever you are logging in, the usernames have to already be created. Most SSH devices Enabled devices have a AAA server that they use, which is covered later. And AAA servers are just used to maintain basically different users and things like that, and give them different priorities and their restrictions and stuff like that whenever they're logging into switches, their permissions. But that's how you configure SSH and Telnet. If you have any questions, feel free to reach out and ask me. But thanks for watching.